Hey everyone, thank you so much for joining today's session on rethinking wildfire detection, how earlier detection can help protect communities and natural resources. We've gotten through the technical difficulties. Hopefully it's pretty smooth from here on out. But before we dive in, just a few quick housekeeping notes. We are recording today's session and we'll share the link with you afterwards. So please keep your mic and camera off so everyone can hear clearly, and hold on to your questions, drop them in the chat as they come up, and we'll cover them in the end in the Q&A. So here's where we're headed today. We'll start with quick intros, then look at how our changing climate is intensifying wildfires and what the data actually shows. From there, we'll get into Dryad Sylvanet Suite and how Woods Hole Group's expertise bridges that technology to your world. We'll do a live demo, cover what sets Dryad apart, including Dryad's X Prize results, and hopefully leave plenty of time for your questions at the end. So let me introduce today's speakers. I'm Salvador Garcia, joining you from Washington, D.C., leading telematics market intelligence at Woods Hole Group, where I focus on advancing wildfire detection technology across North America. And joining later from Berlin is Karsten Brink-Schultz, CEO and co-founder of Dryad Networks, a serial telecom entrepreneur whose team is an X Prize wildfire finalist in the autonomous wildfire response track. Also in Berlin is Eric, who popped in earlier, Dryad's global technical pre-sales consultant and North America's sales lead, supporting everything from solution architecture and deployment planning to post-deployment optimization. And the star of the show will be the Sylvanet wildfire sensor. Its superpower is that it could smell wildfire before anyone sees it and alerts authorities. I'd also like to recognize the marketing team behind the scenes. This webinar wouldn't be possible without Erica Greenfelder at Woods Hole Group and Anna Salsac Jimenez at CLS in Toulouse, France. So Woods Hole Group brings 3 decades of environmental monitoring and satellite data expertise to the US market. And as a certified Dryad reseller, we pair Dryad's ground level ultra early wildfire detection with our earth observation and forecasting capabilities, giving customers a single solution that sees fire risk from under the canopy to orbit. Now about wildfires and how they're changing landscapes impacting the Americas. So far, in 2026, for instance, in the United States alone, we've already seen over 37,000 wildfires burn 3.4 million acres across the US. That's 130% of the 10-year average for the number of fires and 146% of the average for acres burned. In other words, we're not just seeing more fires, we're seeing bigger, more destructive ones, and we're only partway through the year. The damage goes beyond the flames themselves. Environmentally, ash and debris contaminate water supplies, and soil restoration can take years. Socially, fires displace residents, deepening housing shortages, and hit older adults and marginalized communities the hardest. And economically, small businesses struggle to reopen, and insurers are pulling out of high-risk areas. But here's the key takeaway. Every dollar spent on preparedness saves up to 13 in recovery. So what do all these numbers add up to? 3 things. First, the trend is clear and it's accelerating. This isn't a bad year, it's a direction. Second, the damage is systemic. It ripples across our environment, our communities, and our economy. And third, the one thing we actually control is time. The earlier we detect a fire, the more of that damage we prevent. And that's exactly where Dryad comes in. This shift, I want you to hold on to for the rest of our time together, moving from reacting to fires to detecting them at the earliest possible moment, the smoldering stage, before there's even a flame visible. That's what Dryad and Sylvanet system are built to do. Let me show you how it works from the sensors in the tree all the way to the alert on your screen. Time is of the essence, but I want to be clear about how to read this chart. because it's not about one technology beating another. It's about using time wisely, and each of these tools earns its place. Satellites are powerful for modeling where a fire is headed. That intelligence keeps hotshot crews safe and helps command decide where to focus resources. Cameras, they're excellent for validation and verification across huge swaths of land. But there's a gap. By the time the smoke plume reaches a dense canopy where a camera can see it, the fire has already been raging in the understory. That's the window Dryad closes. Sylvanet completes the wildfire technology detection stack. Its ground sensors sit in the forest and smell the earliest chemical signatures of combustion. Together, that's a complete picture. Detect early, verify, and model the path forward. So let me introduce the sensor itself. This is the solar-powered gas sensor that smells a fire within minutes of ignition. It runs for 10 to 15 years maintenance-free with no lithium-ion batteries to fail or replace. On board, it's got AI-powered edge computing, so it makes the detection right there in the tree, and it communicates two ways, LoRaWAN mesh and direct to satellite. So it works even in remote areas where cameras and cell coverage can't reach. The mesh, full of readings, still needs a bridge to reach you, the border gateway. It ties up 10,000 sensors. It ties up to 10,000 sensors and carries everything over 4G or wired Ethernet. It's solar powered, rugged, built to sit in the field for years. But when there's no gateway and no cell coverage at all, the sensors have another way out. On satellite, each sensor runs in two modes. In weather station mode, it collects readings hourly, sending them every 4 hours, your baseline picture. In fire detection mode, it samples every second and batches up every 6 hours. But the instant it senses an anomaly, it jumps to every minute. The real fire triggers an alert straight to your team by email or SMS. Everything the sensors and the gateway gather comes together here, the Sylvanet Cloud platform. This is where your team actually works. It handles deployment planning, manages every device in the field, and drives your monitoring and alerting. But it goes beyond alerts. It does fire risk analysis and spread modeling, so you can see elevated risks before ignition and pre-position resources on the highest risk days. And because it's an open platform with API, it plugs into the system your agency already runs. The Alert Center, it's built to fit into what agencies already run, not replace it. Detection can show up on your GIS map as part of the common operating picture, open or update an incident in the ops dashboard, trigger automated API workflows like pulling up a nearby camera, and push alerts to the people by email, SMS, or web. And you decide the rules, who owns the system, how it retries, what gets logged, and what dispatch authority, all defined before launch. So that's how alert reaches you, however you set up your preference. But the real test isn't in the demo, it's the field. So harsh conditions, how densely you place the sensors, and environmental cues that actually drive a detection. To walk you through that and 3 US deployments already running, here's Eric.
Thank you, Sal. So branching off from the Alert Center, we also want to take into account that the sensors will be deployed in a variety of different places. We designed them primarily to be deployed in forests, but urban areas and industrial areas are also at risk, and we have taken this into account. So we have two ways or two settings for the sensor alerts. The initial alert is the traditional one, which if you detect a fire, then the first alert that comes through, you receive an alert as a fire alert. But if you want further confirmation and you have deployed in an area where there could be a lot of sources that may trigger an alert, then you can put it in harsh environment mode. What this does is that if a sensor detects an anomaly and then it triggers an alert, it will first send it as an early alert. And if there's a second sensor within 300-meter radius that triggers an alert as well, then you get a second alert. And now this is considered as a full-blown fire alert. What this does, it gives you different methods which you can react to the alerts. And also this allows you to plan the way that the personnel and the people working with you will be able to react to those alerts. Now, we consider CivilNet the Internet of Trees. And we say this because using IoT, we put the sensors in the forest, especially in areas that may be challenging for connectivity, and we have been able to establish that connectivity. Every year, we try to push forward with what we can do with our devices and try to solve more challenges with them. And as Sal had mentioned, with the border gateway, you have multiple modes of connectivity. As you can see here in the diagram, you can connect the border gateway to cellular connectivity. You can also plug it directly to Ethernet and have direct power. And then the sensors connect to the mesh gateway whenever needed for extending that connectivity in the forest, or directly to the border gateway, or if you like as well, directly on satellite connectivity. It can be as backup, or it can be for full satellite connectivity. We also have designed the system to work in tandem with other solutions, and we'll be talking more about that. But this is a clear path forward for a lot of the clients that we're having now, where they don't just adopt one solution, they want a full ecosystem of solutions so that you can cover every base before the fire gets out of control. So to give an example, we have 3 distinct US deployments right now. The first one is Mediterra, which is a big community that is intertwined with natural preserves and also other services like golf course. So it's one of those communities where people have really nice homes. They come for a certain period, and then the rest of the year they go to different states and stay at different homes. But the area is immaculate, and they have a problem that they're running into issues where they clean the preserves and they do regular yearly cleanings, but it's costing them north of $1 million to do these regular cleanings. So they want to try to find a solution where they can protect the preserves and also the houses that are adjacent to the preserves. The best solution for this would be our system, because we have placed 622 sensors, which give it about 70 meters of spacing in between or so. And what this allows, it creates a network that will cover every inch of the preserves. And in case that there's a fire of any kind, then we will be able to catch it at the earliest minute possible. So this was essential for them. There was no time to waste, and they already have had fires from the last year, and even some this year that have been getting really close. So it's been a pressing matter for them. The second one is in a completely different environment. Cordillera Metro District is in the process already installing their sensors. They will be installing 750 sensors and will be done by August. So this is higher up in the mountains, still protecting forests in a community that is adjacent to forests, and they also have a lot of open fields. Grass fires can spread really fast. So they prioritize the areas that are hard for them to reach. If you start from the entrance of the community all the way till the end, it takes you about 40 minutes to get there by car. So they want to cover all the areas that they can, all the blind spots, and they're also using our system in tandem with cameras, and they're also going to have drones, fire suppression drones in the coming months. So they're going full steam ahead with all the solutions that they could use to form a stacked protection layer. And then the last one is the Jackson Demonstration Forest up in the north of California. This one is one of the sites where it really pushes our devices to perform the best they can, because in the redwood forest, you have very little light. The density of the forest makes connectivity challenging, but even then, our system performs very well in this type of environment. Very humid, very dark, and hard to get to. So in these 3 examples, you have applications in different environments some more urban than others, but through this, you can see that the system is applicable throughout many different areas. So when you look at the number of the sensors and the density, you start to wonder, okay, what is the type of density that we try to approach? And it varies depending on the site. Typically for high protection, we go for 70 to 100 meter radius. And this is to ensure that we can detect the fire the quickest possible. And with the way that we deploy in the grid, then we ensure also that wind direction becomes a lower factor compared to other sensor solutions who would struggle with a less density, trying to cover a wider area. So high protection density, this is what you would likely put for high value areas, also areas that are frequented by a lot of people, given people are one of the main factors of wildfires. And then also if you want to ensure that you will catch that fire as quickly as possible. Medium protection, this is between 150 and 200 meters, 250 meters. This is between the sensors, this density between sensors allows you still to detect a fire relatively fast, I would say, in comparison to cameras. But this you can apply in areas that you still want early detection, but you can accept some time gap, right, compared to the high protection. Because in the end, what you're trying to buy here is more time for you to react and put out the fire. The low protection density between 250 and 300 meters plus, this is more for monitoring. You will still detect the fire, but as you can see in the image, the further you move away and the greater distance between the sensors, then that early detection is limited to the 150 meter radius around the sensors in its immediate vicinity. So you still have protection around, the time to detection increases, but this application also is possible for when you just want to do general environmental monitoring. And if you want to do it solely on satellite as well, then the sensors can work purely on satellite in an environmental monitoring mode, and you just get environmental readings. So you have different applications, different densities that you can work with. And when we work with a client to find the best solution for them, we take all of the variables into account, like the permissions, the right of way, and what are the things that matter to them, and how much time do they want to buy before the fire becomes catastrophic. So when the sensors collect data points, they collect the air pressure, humidity, carbon monoxide, temperature, air quality, and energy level sensors. Depending on the generation of the sensor, you either have air quality or PM 2.5. For the Gen 4, it would be PM 2.5. And all of this data is used to give you the fire risk index so that you also have a heads up and an advance warning in case there's going to be a fire or possibility of a fire in the area, depending on how the different readings work together at different times of days. The platform also will give you different environmental cues, such as humidity, temperature, and all of these will work at an individual sensor level so that you can see which recording, which humidity readings, which temperature, and also which part would be most likely to be problematic, right? So you start the day, you want to check which areas you want to give extra attention for the day, and then through this, you'll be able to see at a local level where it might be the riskiest. Handing over it to Sal for the demo.
I will now kind of show you what the system looks like from the inside. On the left here, there's you'll see the planning overview where there's overlays, areas, paths, and a way to connect the different sensors via gateways. Today, we're focusing on Glenwood Springs, Colorado as an example. Here, we could use overlays to look at the boundaries of the communities, and we could also use the overlay tool to look at historical wildfires in the area, and it's clear that Glenwood Springs has seen some things. So I'm going to first show you the line tool. And in this example, what we're going to do is with the line tool, what this helps us with is to be able to plan, automatically plan where the sensors will go. So you'll see once you have created a path of where the sensors could go, a new menu shows up. And by default, it's a hiking path. There's also a road path. There's a railway path. There's a power line path, and there's also a linear path. Then below that is the sensor selection detection. I prefer the Gen 4 Pros with satellite fallback because it's good to have that redundancy feature. And just below that is the protection density. Here you could modify the density of the sensors, and this tool will automatically space them. So if you want to lower the protection of the area, because it's all about time, like how soon you want to be alerted, you could separate them. And you could see the level of protection using this green shield tool here. And if the fire happens within the dotted lines there, you will get really quick detection on the wildfire. But beyond that, it would be a bit slower. So that's the line tool. For the next tool, I'm going to show you how to use the area tool. And I like to, in the area tool, switch over to the Google Maps sort of view, because you can see all the homes and areas. You don't want to deploy sensors too close to homes. So this is really good for that wildland urban interface planning for more sparse deployments. So here I am just avoiding existing infrastructure and just making an area. So here by default, it'll show the distance between sensors at 200 meters. The protection, it's pretty well covered. If this is a high risk area, you could always increase the density. Maybe it's a hiking path where burns, ignitions are often reported. So that's the area tool. Once you're done with the area tool, you then want to start planning where gateways can be installed. And this planning tool has a really nice feature where you could automatically start to place the best locations for those gateways. The gateways are what connect to the cellular network. Remember, all the sensors do have satellite, and you could use that, but with the gateways, you're able to get a constant flow of data where there is cellular network. So it will continue to, as you can see, it's making like a blue line, a blue region there. That's kind of looking at, depending on the terrain, how far the signal will go. In this case, I chose the installation of gateways on a 5-meter pole. And it will keep going until it gets to about 80%. And once that gets through, it will then have sort of its final recommendation. And exactly the latitude and longitude where it will be placed. And that is how you use the gateway tool. And it's good to have that coverage in those areas. This is what a full deployment may look like for Glenwood Springs, Colorado. There's protection around the entire border, and in this case, I created I only needed 4 gateways with 10-meter towers, so that's much higher there. And this is just a conversation starter. What's important is to speak with local stakeholders and get their opinion about where sensors should be placed. So I hope you enjoyed this part of the tool. And now I'd like to introduce you to Dryad. Dryad is, or the CEO of Dryad, Karsten, who's going to talk about the X Prize Wildfire Finals and his experience there. So thank you, Karsten.
Yeah. Thank you, Sal. I've got the pleasure to talk to you about a very recent development and very exciting future development of Dryad, and that's the participation of Dryad in the X Prize Wildfire competition. For those of you who don't know this competition, it's a 4-year competition that originally 300 companies entered into to create autonomous fire detection and autonomous suppression systems. The vision of the XPRIZE Wildfire was, and still is, to create a system that would detect and extinguish a wildfire within 10 minutes from ignition. So not just the ultra-early detection, as you've heard, which Dryad is very good at, but also to take the next step, and that is to automate the response to a wildfire, typically with drones to respond to fires and then attempt to extinguish them. So Dryad now is working in these directions. As you've heard, we already have a system with SilverNet that can detect fires within minutes from ignition. And we're now working on extending this system into the vision that XPRIZE Wildfire set out, and that is to build an autonomous wildfire response system that takes wildfire detection to the next stage, which would be to observe and suppress a wildfire. And for that, we're building a system we call SilverGuard. The SilverGuard consists of 2 autonomous drone systems. One is an observation drone that once a sensor detects a fire, autonomously flies to the location and that the sensor has reported the fire and scans the area with infrared cameras to precisely geolocate and measure the fire. Once the observation drone has geolocated the fire, SilverGuard autonomously launches a suppression drone, which can suppress small fires with a heavy lift vehicle and about 100 liters of water. It's about the size of a bathtub that we carry with this heavy lift drone and then apply it to the fire with an attempt to extinguish it. Next slide, please. So the XPRIZE Wildfire set out a competition. As I said before, originally 300 companies were entering into. At the end of June, we had entered the finals. And in the finals, just 3 competitors were left, Dryad, then Anduril, and Aurora Foresight. All of these 3 companies were invited to deploy their systems in Alaska in a very large area of about 1,000 square kilometers. The teams deployed their systems with the intention and with the goal to demonstrate detection and autonomous suppression within the 10 minutes time window from ignition. Next. So Dryad, we deployed our system, obviously the SilverNet sensors. We deployed 169 sensors in the area to perform the ultra-early detection. We also deployed 4 gateways that would enable the sensors to communicate to the internet. We also added a camera system by a French partner company to observe the performance of the system, and then obviously the SilverGuard autonomous drones, the observation drone, and the suppression drone. The whole system was controlled with a cloud platform that Dryad has developed that can oversee the operations of both the sensors and the drones. Next step. So here are a few pictures and impressions of how Dryad deploying the systems. It was quite a remote environment, very difficult terrain, and we took about 3 days to install the 169 sensors. You can see pictures here of the team working its way through the difficult environment in Alaska and the sensors being deployed in the wild. Next, please. This is a picture of the Dryad team and our systems. You can see a picture on the right, on the lower right, of the observation drone on the floor, and the suppression drone there being on display, as well as the gateways and the sensors. This was a picture taken after the performance of the test to show our systems components to visitors that attended the finals testing. Next. Here are a few pictures of the Dryad SilverNet and SilverGuard system here, in this case, the drones operating during the test. And you can see in the middle the suppression drone flying and applying 100 liters of water to one of the test fires that were set out by the judges during an 8-hour test when Dryad had to perform. Now, I cannot talk about the performance or the results of the competition. That is not what I'm allowed to do at this stage. All I can say is that I was quite happy with the performance of what we did and the team achieved. And the judges are now reviewing the results of the 3 competitors and will announce the winner on the 23rd of September in New York during Climate Week. That is when the winner will be announced, and the 4.5 million prize will be distributed to the winning team. Let's hope that Dryad will win. Obviously, that's what we would hope. And I'd like to say thank you with the impressions of what we did in Alaska. So back to you.
Thank you for that, Karsten. Eric, if you could join us on stage as well. I want to thank everyone for participating in this webinar. And now we're going to go right into the Q&A. So if you have any questions, start dropping them into the chat, and we will start covering them. Looking at the chat right now, here's a question from Ashton, who asks, how does Dryad disentangle smoke from a nearby fire versus smoke that's drifted in from fire far away? Think about a fire burning in Utah whose smoke has drifted and settled into Colorado.
Yep. Maybe, can I take that?
Yes,
I have one of those.
go for it.
I've got one of our sensors here. That's a Gen 4 sensor. And if you look at what this sensor has, it has 3 sensing components. It has a PM2.5 sensor where it can detect particles that fill your lung with the smoke of the wildfires, unfortunately, and it's called haze, basically. So this PM2.5 sensor will pick up haze, it will pick up particles, and will see also the smoke that has drifted from Utah into Colorado. So this sensor will detect that. But we also have 2 other sensors. One is a CO sensor, a carbon monoxide sensor, and a volatile organic compound sensor, a VOC sensor. And in combination, these 3 sensors make sure that we're not going to alert you for what's called haze. And that's basically the effect that you're describing here, the smoke of a fire that's in Utah drifting into Colorado. So the Gen 4 sensors will be able to distinguish that and not give you a false alert. And in case there is a fire nearby, the haze condition, obviously you will see VOC and CO signals going up, and the sensor will be able to detect those signals and alert you for fire even under haze conditions.
Yeah. And just to add to that, when the sensors are deployed, they form a baseline of the current microclimate of each individual sensor. And of course, over time, the longer the sensors are deployed, the better understanding that they have of what's normal and what's not in the current climate. And throughout the year, when there's haze, it may elevate the baseline, and after a few days, that new baseline is adopted so that the sensors can still detect a fire when there's a fire within its radius of detection.
Thank you. The next question is, can the sensors discern a dangerous wildfire from normal benign campfires? From what I understand, go ahead, Eric, you got this. Go ahead.
So as Sal had mentioned earlier when he was demoing the planning tool, it really depends on what is the goal of the end client. We have some clients that would want to detect illegal campfires, and we have other clients that their primary goal is general protection of the forest or the area that they're in. When we take those into account, and we also look at how close are the homes, what other possible sources of fires do we have nearby, then we try to keep a certain distance between those areas so that we can minimize the possibility of false positives. Because the sensors, they're designed to detect wildfires and the material burning from wildfires and the VOCs that are specific to wildfires. So put a campfire close enough, long enough, it will be able to detect it depending on how big it is. But give it a little bit of distance, and depending on the intensity, then it won't be a problem. So it really boils down to placement and taking care of what are the client's needs.
Thank you for that. Thank you for that question, Kevin. Ralph asks, what is the top wind speed it can operate, and how can it get under the dense canopy for application of water, or it is only for grass and shrubland? And then is it just water on the drone? I'm not sure about the top wind speed that it could operate, but in terms of getting under the dense canopy, these are deployed under the canopy of the tree, so it's able to emit the signal and alert the user that it's detected an anomaly. And yes, it could be used for trees, or whether grasslands or shrubland. They don't necessarily need to be in trees. We have deployed these on T-posts, on fences that are much lower to the ground, about a meter off the ground. And is it just a water on the drone? What does the drone cost, and what is the range of the drone area of land, and how do the batteries stay charged and ready over space and time? Karsten, maybe you got this.
Yeah, I think these questions were probably directed towards the Silver Guard drone systems, and all very valid questions. Just to start off with, what we've demonstrated and all the teams demonstrated were working prototypes. Just to be very clear, the Silver Guard system is a working prototype. It was fully functional, autonomous suppression, detection of the fires. There was no operator involved. But it is also important to say that this is not yet a commercial application. So as much as we would like to be able to offer the SilverNet system, this will still take time to industrialize and then commercialize. So many of the parameters and the functionality will change. What we've been able to demonstrate is a fully industrialized system with SilverNet that reliably detects fires within minutes from ignition. And on top of that, as an extension, the Silver Guard system, which actually responded to the fire by observing and then suppressing the fire. But to answer your questions, with what we have.
I just wanted to make a clarification. Ralph asks, how does the drone get under the dense canopy of the tree?
It doesn't. It doesn't. So the drones fly above the canopy, and they use infrared cameras to identify the location of the fire and then apply the water through the canopy. Obviously, in leafy canopy, this may be challenging, but in most like fir trees or so, that shouldn't be an issue to reach the fire underneath. So there were a few other questions. We have used only water, but of course, you can apply any suppressant as long as it's liquid. What does the drone cost? We cannot say that yet. It's not a product that we sell. It's a working prototype. What is the range of a drone? We had a range of about 15 kilometers with that drone area of land. So that's the radius, basically. How do the batteries stay charged and ready over space and time? Well, for that, we are working on a hangar, which is a solar-powered hangar that actually protects the drone from environmental issues and keeps the drone charged with solar panels.
Excellent. Bruce, thank you for that question, Ralph. If you have more, drop them in the chat. Bruce asks, how far away do the drones need to be stationed to enable response within 10 minutes?
Well, the drones that we are using are capable of flying at speeds of 100 kilometer an hour. I think that's about 60 miles or something like that per hour. So you can do the math yourself. That you also need to take into account, of course, the operational distance. But again, I'd like to say that the current systems are working prototypes. These are not yet products, and we would envision, 1.5 to 2 years before such a system could be commercially operated. And by then, of course, technology will have advanced.
Excellent. Thank you for that. Let's see. Alex has a question about, has your deployment testing included biomes outside of the US? My focus area is Africa, and it's predominantly savanna. Interested in any deployment impressions within that context. And he says, good luck on the X Prize. Fingers crossed for September.
Well, for the SilverNet system, we'd say we have more than 70 live installations worldwide. We have obviously the installations in the US that were talked about here today. We've got about 30 installations all over Europe. We've got deployments in Asia. And we also have a few in Africa, specifically the savanna. We currently don't, but we don't see that there is an issue. We've deployed in all various biomes, from dense jungle in Thailand all the way to the redwoods in the United States, and boreal forests in Alaska and Europe. So our system really works in all variety of biomes. It's not specifically limited to what we've seen in the United States.
Thank you for that, and thank you for your question, Alex. Let's see, any more questions or thoughts that have that are on the tip of your tongue? I think we've done a really good job in explaining Dryad. Maybe that is, yeah. All right, well, if there are no other questions, but maybe for right now, but a question pops up, this is our contact information for you to reach out to us. If you're interested in using the software and planning for your community, please reach out to me. I'd be happy to get you access to the Dryad software so that you could start planning for your own community and see how many sensors it would take to cover. Yeah, well, thank you so much. Thank you, Karsten and Eric, for joining me today for this, and good luck on the X Prize.
Thank you, Sal. Thanks, everybody.
Thank you, everyone. You have a great day.